Hello children, good morning. I hope you have learned the previous concepts what we had discussed in the previous class. Right? So now we are moving to the next concept of this mechanics unit, which are laws of motion. Right? So first we have what are the concepts we have to recall. In the previous class what we have done, excuse me children. In the previous class we have done few sums based on distance, displacement, velocity and acceleration. So that sums you had understood a little bit children. Okay. With that, let us move into this. Now we are going to see about 3 Newton's law. Right? Sir Isaac Newton was a great scientist and he gave 3 laws of motion. And along with that 3 laws, he explained some of the other concepts also. That is what we are going to see now. Come, let us move into first law. First you have to understand what is law, right? So law is a statement, right, which explains about a truth, right? And this just cannot be stated by a person. It has to be stated by a person, and so many scientists will check on it, experiment on it, and they have to approve it, and then only it has to, it will be released as a statement, as a law. It is a universally accepted fact by scientists and then by common people, right? So right now first he gave 3 laws of motion. When the body is under motion or in state or in uniform motion, it has 3 laws has to be discussed as stated by Newton. Okay. So what is Newton's first law? When you are writing law children, the statement must be as it is in the textbook. So whatever statement given to you through your textbook, write as it is. You cannot change it on your own. Okay. So what is the first law? Every object will remain in its state unless it is compelled by a net external force. Right? So now when a ball is there, right? Now I am having it on my hand. So now I am checking on it. When this ball will move. So how long can I wait for this ball to move? So it will move when I apply one external factor and take it or move it or push it or pull it. Right? Till I apply that, this ball cannot move. This happens for every object. Right? So now what is the concept? Every object, whatever may be, see now I am moving from one place to another. It is due to the muscular force given by me. Right? So now what is this? Every object will remain in its state. Whether a body is maybe at rest or in motion or in uniform motion. That is what I have given here down. Motion, rest or uniform motion. Right? I told you before the previous class, rest and uniform motion are similar. Similar in the sense not exactly in the state, but in the consideration. Rest means without moving. Uniform motion means what? Moving with the same speed for a continuous time. Right? So both will be considered as the same one. Why? Rest means its speed is not altered. If a body is moving with the same speed means what? Its speed is also not altered, changed. So rest and uniform motion are literally considered to be the same, right, in physics. And what is the other state? Motion. So if an object is in these 3 states, to change from this state to another state, the body cannot change by itself. An external factor must be applied. That external factor is called as force. What is that? Force. So simply we can explain force as push or pull given by a body. Okay. So what is the first law? Every object will remain in its state unless it is compelled by a external force. Right? Now, what are the concepts explained by first law? The concepts explained are force, inertia and mass. So here force I told you now, explained you now. What is force? It is an external factor which changes the state of a body. Right? The state means it may be rest, uniform motion or motion. Right? So it is an external agency. Now first I'll explain you mass and then I'll come to inertia. What is mass? It is the amount of matter contained in a body. For example, if I'm a human being here, I am human being. What is the amount of matter? How much muscles, bones, right? So like that, how much matter is contained in our body, right? If you take a book, how many papers, how much is the quantity of substance occupied in it. So that goes for its mass. Now, what is this new word, inertia, right? So I tell you an life example, right? So while waking up in the morning, how many of us will wake up in the first call of our parents, right? So many of us will wake up at the second call or third call. So, but some people, great people, will wake up after getting a kick from your parent, right? Right. Now, like that, every object will have some, what is that, inability in them. Inability. Inability means what? It have a tendency not to change to the other state. Okay. So that inability is called as inertia. What does that tell me, children? It is the inability of a body to change from one state to another state. One good example I will tell you. At your home, when you are sweeping, when you are cleaning your carpet, right? When you just take up the carpet, the dust will not fall down. A few sand-based dust may fall down. To clean it completely, what we have to do, we have to give a jerk or we have to blow that carpet to the wall. Why? The dust attached to the carpet will have some inability to come from the state of rest to state of motion. So what we have to do? We have to give a blow with the broom or on the wall. Then the force is given, sufficient force is given to overcome the inability. Then the state of rest is changed to state of motion for the dust particles. Another example I will give you, if you are there in a moving bus. Right? Moving bus, if you are traveling, if the driver applies a sudden brake, what you will do? You will just lean forward and you will come back. Yes or no? Why you feel like that? Because the bus was in the state of motion. Right? Suddenly the driver applies a sudden brake. Means the body comes to the state of rest. Motion to rest. But your body was in the state of motion. Your body will have some inability to immediately change from the moving bus to the rest. So due to that inability, what you will do? You will move in the direction of the bus and then you will get back. So now this movement will give you the force to change from motion to rest. Understood? Now one another example I will give you. While you are taking a turn in sharp turns, what you will do? When you are taking along with the vehicle, your body also will take it and you will get a hold of something. Have you ever experienced this? Right. So because if you are moving in a straight line, suddenly you cannot take a turn. So your body also, you have to adopt your body to change according to the changing direction. So that is called, force must be given to overcome that inability. So that overcoming process will be done by applying sufficient force. So that inability is called as inertia. Clear, children? So now this inertia is of three types. One is, underline this in your book, inertia of rest, inertia of motion and inertia of direction. What is inertia of rest? I told you that carpet example. Right? So inability of a body to change from rest is called as inertia of rest, and the sudden brake, moving bus, that is the example for inertia of motion. Inability of a body to change from the state of motion is called as inertia of motion, and this sharp turn, adapting yourself towards the turn, that is called as inertia of direction. Okay, student? So there are three types of inertia. As this first law explains about this inertia in a very detailed way, this first law is otherwise called as law of inertia. Underline that point in your book. So first law is called as law of inertia. Clear? Right. Now how inertia is related with force and mass? If mass is more, inertia also will be more. If mass is less, inertia also will be less. Right? Now I'll tell you an example. Now if a heavy truck is there, so why to go there? Take this wall where this board is attached. Right? Now if I apply force, right? Now can I move this force? It is in the state of rest. I am applying force to overcome inertia. What to be applied? Force. Now I am applying force, pushing it. I can't do it because the mass of the board along with the wall is very high. But if I have a ball or even a ball like this, right? See, now I am applying a light force only. I am moving it. It is in the state of rest and easily it is coming to the state of motion because the mass of these balls are less. So when the mass is more, inertia will be more. Mass is less, inertia will be less. Simultaneously, if mass is more force to be applied. See, I may not damage this, but if any heavy truck or heavy force, what is that? With the weapons, I can do that. Change this, move this, right? So I can create the damage to this, right? So that is applied amount of force. So if mass is more, inertia will be more, and more force needs to be applied on it. So if mass is less, inertia will be less, and less force alone is enough to overcome that inability. Right. Now what is the second factor? These are the concepts explained by first law, children. Now we are moving to the second one. The rate, first I will move with the statement. The rate of change of momentum of a body is directly proportional to the applied force, and the change happens in the direction of the force. First, before getting into the statement, I need to tell you what is momentum and what is impulse. Right? So now this you are not in your 6th standard itself, but I will give you a remembrance. Right? So what is momentum? It is the product of mass and velocity. So when you multiply mass of a body with its velocity, then that answer, that product you get is called as momentum. Its symbol is small p. Right? So now it is a vector quantity. Now you recollect what are scalar and vector quantities. This momentum will have both magnitude and direction, so it is called as a vector quantity. Now what is its unit? Mass unit is kilogram and velocity unit is meter per second. So momentum's unit is kilogram meter per second. Now it will have another unit, Newton second. Now you add this unit and learn how that Newton second is the unit of momentum. You will learn in your next year, 8th standard, you will learn it. Right? Now what is momentum? Its symbol is P. It is the product of mass and velocity. Its unit is kilogram meter per second. And also it is Newton second. Now we have another factor called impulse. IMPULSC. Its symbol is capital G. Right? Now you may have a doubt here, students. Why for momentum we are using P, small p? Because if we use M, it was used for mass. So that's why scientists had some other denotion to use P. Right? So now impulse will have the symbol capital J. Right? What is this impulse? It is the product of force and time. Here this is the product of mass and velocity. Here impulse is force and time. I'll tell you a real time example. When you are traveling on a vehicle, any vehicle on the road, right? Suddenly one another vehicle with a great speed will dash against next to us, right? What is that? Very near to us, very fastly it will go and our air and all will get blown up. So have you ever experienced this? Right? So a very greater amount of force acting for a small interval of time will create a greater impact. One best example shall I tell you, children? When someone slaps you on your cheeks, a greater amount of force applied on a body for a short interval of time. How much it will pain you? will be more, no. So that is called impulse, a greater amount of force applied for a short interval of time. This is the practical meaning. But mathematically it is force acting for a particular time, force into time. In general, we will explain how momentum is getting changed. What is momentum? P is equal to mv. How that momentum gets changed? Either it is faster or it is slower. That is called impulse. Clear, children? So J, impulse is equal to force into time. So force unit is Newton, time unit is second. So unit of impulse is also Newton second. So now here one comparison you can learn now. Unit of momentum and unit of impulse is the same. Newton second. Now this is also a vector quantity. It will have both magnitude and direction. Okay. Right. Now coming to this. You explained, you had understood these two. Now come to this. Rate of change of momentum. Momentum means what? P. P is equal to what? M into V. Right? Rate of change of momentum. Rate means what I told you in the previous classes. Any concept divided by time is called as the rate. Right? In our previous classes we learned no, rate of change of velocity is called acceleration. Like that, rate means we have to divide that any quantity by time. Here, rate of change of momentum. Momentum means P. P means what? mv. So that is what I have written here. Change means what? Final momentum and initial momentum. What is your final momentum? Momentum means what? Mass into velocity. What is final momentum means we have to use final velocity. What is the symbol for final velocity? V. So mv is the final momentum. Similarly, mu is the initial momentum as u goes for initial velocity. So this is the change of momentum. Final momentum minus initial momentum. This change by time is the rate. Rate of change of momentum is directly proportional. I have explained you this proportionality in the previous classes. If one is more, another quantity is also more, that is directly proportional. If one is less, another one is also less, that is directly proportional. If one increases, other decreases, and one decreases and other increases, that is indirectly proportional. Here, as per this law, rate of change of momentum is directly proportional to the force. Right? Now I am bringing everything to this next side, this left side. Right? Force comes here, this quantity goes here. How it goes here? Mass is same? No. So I have taken it out. So I get V minus U inside. Mass V minus U by T. But what is V minus U by T? Rate of change of velocity. Do you remember the previous concepts what we have learned? V minus U, final velocity minus initial velocity. Rate divided by time. Change minus of velocity, final velocity minus initial velocity. What is the subtraction concept? V minus U by T is called as A, acceleration. Rate of change of velocity is called acceleration. So F, this one automatically comes to proportional MA. F is proportional to MA. So this is what I have explained by second law. So what is the equation of second law? F is proportional to MA. Actually, for your sums, when you do it, you consider that F is equal to MA. How that proportionality changes to 1 equal to, you will learn further in your next lessons. Okay? Right. So this is the second law. This is the equation of second law. Now we have finished up to here. Alright. Now we have to know about collision. Collision means what? Hitting of bodies. Right? If two bodies hit on each other, for example, I have two balls here. So now when two balls collide with each other, so some impact will be created here. That impact is called collision. Right? So this collision is of two types, children. They are elastic collision and inelastic collision. Elastic collision is nothing but no energy loss will happen. What I did now. So now two bodies collided and one had fallen down. Is there any energy loss? No. The body remained the same. So this type of collision can be considered as elastic collision. And in elastic collision there will be energy loss. For example, this light, the sound I am talking, the sound is just getting collided with the substances around me. Now as I talk, as this collision continues, this energy of the sound wave can be reduced. As it reads continuously, right? As it go further, the sound volume can be reduced. No. So the energy will be reduced as collision happens for a longer time. So this is inelastic collision. So these 2 points are not in your book, so make a note of it. Right. Now we have to know law of conservation of momentum and impulse. So both you have to know. Now I'll come back to this equation. Right. What is this equation? F is proportional to mv minus u by t. Now F is in the numerator, t is in the denominator. That means what? Numerator and denominator are inversely proportional. If force increases, time will decrease. If force decreases, time will increase. Have you ever seen children this cricket matches? Why I need to ask this question? You will see. Yesterday, a few days back only, what IPL got over, right? So in that sixer catches, have you ever seen children any catch? If that fielder catches the ball, what he will do? Immediately he cannot keep his hand here. He will do like this. Why he has to do like this? He or she. Because when he or she does like this, the time of catch will be increased. When the time is increased, what will happen? Time is increased means what? Force will be decreased. So the impact of the ball on the hand will be decreased. So what will happen? His hands can be saved from injury. So now and in long jump and high jump and all, have you seen soft beds only would have been put over there. Why? The athlete will have a jump and they jump on the bed or even on in the long jump also the athlete finally jumps in the sand bed. Why? Because to reduce the effect of impulse and momentum, the body could not be damaged as it is as if it will happen in the original flat over, right? So the time can be increased, the effect of force and impulse can be reduced. Thus daily life examples will be more and more children. Some more examples are given in your page 40 of your book 40. So you can refer to it. Right. Now coming to this. When two bodies collide with each other. Now I will take the same two balls as my examples. So now I will have this as mass 1 and I will have this as mass 2. M1, U1, sorry, M2. M1, M2. Now when they are traveling, before traveling they will have a velocity. Right? That velocity I will take it as U1, U2. Right? And after colliding they will have some other velocity. So final velocity and that will be taken as V1, V2. Right? So M1, U1, V1. Mass, initial velocity, final velocity respectively. M2, U2, V2. Mass, initial velocity, final velocity respectively. Now what is momentum? Product of mass and velocity. So what is total initial momentum? So initial momentum of these two, M1 U1 plus M2 U2. Okay, this is your initial momentum. So that is what I have written over here. M1 U1 plus M2 U2. What is your final momentum? Final means what? Final velocity only we use. So M1 V1 and M2 V2. Right? So we have to add those two. Now I have written over this M1 U1 plus M2 U2, M1 V1 plus M2 V2. What is this law of conservation of momentum? Momentum I have written like P, small p. Right? So this law states that when two bodies collide, when there is no external force, externally no force, these two bodies alone colliding, then initial momentum and final momentum are equal. Total momentum remains the same. Final momentum is equal to initial momentum and initial momentum is equal to final momentum. That is what I have written like equation. This is completely your total initial momentum. This is completely your total final momentum. This is when it will work properly. When there is no external force. The force is given by this ball, acts on this ball, and this acts on this. So no other external force is considered over here. If that is the case, total momentum remains the same. Initial momentum is equal to final momentum and vice versa. Right. Now we are moving to the next concept, children. Third law. A very simple, workless law, but a very important law. Highly applicable oriented. Now this law states that for every action, there is an equal and opposite reaction. Right? This happens even in our life. Right? For example, if I, what is that? Pat on my bench. Tap on my bench. So, this is my action. Right? Opposite way, the bench also will give some reaction. Right? So, bench, what bench gives is reaction, what I do is action. But this action and reaction acts in the opposite direction. Okay, but how much force am I giving? That much force will be given by the bench too. So that is why our hands also will pain. Right? So now another example I will give you while you are traveling on a boat. Right? While you are getting down from the boat, what you will do? You will move forward with one leg, and with one leg you push the boat apart, a little back. Right? So first leg will do the action, second leg will do the reaction. The boat will move in the opposite reaction, opposite side. Right? Now that is your third law, and this is applied in your rocket launcher. While launching, have you ever seen children, a huge amount of fuel will gush out as a fire in this downward direction, but the rocket will fly away in the forward direction. So action, fuel gushing down is action, and rocket moving up is the reaction. Right. So this is an example, and here the bodies reacting in action, opposite reaction, they are called as action-reaction pair. Okay, children. So now these are the concepts explained by the three laws. Now one size idea has I had written over here. First law will tell you how a body will behave under the action of balanced forces. If a force acts, how a body will react. That will be given by your first law. Right? Now second law gives when a body is in a motion condition. Right? What will be the amount of force? What is the value of force? What is the definition of force? All those are given by second law. So F is equal to ma, we told about this. F is equal to ma. So it gave the value of force. Right. Now third law, when one object exerts force on the other, what will be the effect? So that was given by your third law. So this idea I will be rightly, correctly and with full statement I will give you in the notes. Right. Now we have two sums over here. So that we will explain now. This sums are not in your book. So I have given on my own. So write it down. Right. So notes I had given you this. Calculate the force on a body of mass 20 kg moving with an acceleration of 5 meter per second square. So what is given? Force is, we have to find, mass is 20 kg, acceleration is 5. So what is the formula? F is equal to ma, mass is 20 kg, acceleration is 5. Underlining the key points and all, hereafter I will not do. As I am not saying, there is no idea that you should not do it. That is automatically you should do it. So 20 into 5. What is 20 into 5? 100 Newton. Right? So 20 into 5 is 100. What is the unit of force? It is Newton. So this is how the first sum can be done. Now second question. Find the final velocity of a body of mass 2 kg colliding with another body of mass 5 kg reaching velocity 30 meter per second. This I tell you the same example, children. Now there are two bodies, right? One body mass is 2 kg. Example. Another body's mass is 5 kg, right? So they are each starting from rest and colliding. So initial velocity is 0. It will not be given in a question. It is understood. So colliding means initial velocity is taken here, considered here as 0, right? So now one body that is mass of 5 kg is reaching a velocity of 30. So what is the final velocity of this body? So that is what your question. Now simple, everything is given over here. Mass 1 is what? 2 kg. Mass 2 is what? 5 kg. Whatever may be the initial velocity, they are starting from rest. So initial velocity will be 0. So u1 will be 0, u2 will be 0. So here m1 v1, m2 v2. This is what? Law of conservation of momentum. So now this the whole term. Whatever it is multiplied by 0 becomes 0. 0 plus 0 becomes 0. So this whole term I brought here, this term I have brought here. So no sign change. Right. So now what is mass 1? 2. V1 we doesn't know. That is what we are going to find. That I have written here. M2 is 5 kg. U2 is 30 meter per second. Sorry, V2. Right. 5 into 30 is 150. When that 150 goes that side, it will go as minus 150. And now this 2 is in multiplication. When it goes that side, it will go as solution. 150 by 2, which is equal to 75, which is minus 75. What is the unit? It is the final velocity. Velocity's unit is meter per second. So 75 meter per second with a negative sign. And that negative sign shows that the velocity is decreasing. Clear, children? So these are the concepts you need to learn under this. Be ready with the notes. We will meet in the next class. Thank you, children.